Hello and welcome. You should be on page 39 of your Algebra 1 Quarter 3 notebook. We are finishing up the try-it problems of factoring trinomials with leading coefficients greater than 1 here on page 39. We have one problem on this page and then we're going to go to the next page. So let's take a look at this. 4x squared minus 13x minus 12. Is there a GCF? Well, there's no number that's going to go into all three of these terms and no variable. So I say no GCF. Looks like I got an A of 4, a B of negative 13, and a C of negative 12. Well, if I draw my big X here, I'm going to do 4 times negative 12 and get negative 48, and B is negative 13. So let's think about my factors of negative 48. I know I've got 1 times 48, 2 times 24, 3 goes into 48, 4 plus 8 is 12, so 3 is 16. And I'm going to stop here because I know 16 minus 3 is 13. I've got to get to 13. And if I made negative 16 and a positive 3, I would get to negative 13 through addition and negative 48 through multiplication. So I've found that. Let's write this out longer. Minus 16x plus 3x minus 12. Okay, I need this into two distinct binomials. 16x plus 3x minus 12. And it is time to pull out a GCF. Remove a GCF. It looks like 4 will go into both 4 and 16. So there's my numerical GCF, and I can take out 1x. 4 divided by 4 is 1. I don't need to write that coefficient. 2 minus 1 is 1, so I have an x left. Minus 16 divided by 4 is minus 4. 1 minus 1, that's x to the 0, which goes away. Now, I am going to take a 3. 3 divided by 3 is 1. X is left. Negative 12 divided by 3 is negative 4. Happily, I've got my common binomial factor. And these two pieces are going to be my next binomial factor of this trinomial. Let's move on to page 40, and I want to take a look at these quotients. And remember, we're not really doing anything with the denominator until the end. Our first order of business is to look at this trinomial in the numerator to see if we can factor it. Doesn't look like there's a GCF. You should still look for a GCF. So when I draw a big X here for that, remember, I'm going to look at my A. It looks like A is 6, B is 31, and C is 5. 6 times 5 is 30, and 31 up here. Well, I know 30 times 1 is 30, and 30 plus 1 is 31. So I have got very clearly my two factors here. So I'm going to write my numerator long or out in a longer way, I guess. I don't know. 1x plus 5. Now I need to write it into two distinct binomials. And you're going to notice I'm writing the 1x because I'm just trying to keep out that as an idea as a GCF. So 6 goes into 6 and 30, and I'm going to take one of the x's out. 6 divided by 6 is 1, and I'm left with an x, 2 minus 1. 30 divided by 6 is a plus 5. 1 minus 1 is x to the 0. Greatest common factor here is the 1. So 1 divided by 1 is x, and 5 divided by 1 is plus 5. So if I take 6x plus 1, that's a 1, and I have an x plus 5 here. Now remember, it was all over x plus 5. I've got numerator and denominator, something divided by itself is 1, and my answer is 6x plus 1. That is my final answer. Alrighty, here we look at number 8, similar type of problem, except I do see that I can pull out a 5 here as a GCF. I've got a greatest common factor of 5. So 30 divided by 5 is 6x squared, and negative 5 divided by 5, negative 1x, and negative 10 divided by 5 is minus 2. Excuse me, I have to get my big X here. It looks like A equals 6, B equals negative 1, and C equals negative 2. 6 times negative 2 is negative 12, and B is negative 1. All right, if I think about my factors of 12, I've got 1 times 12, 2 times 6, 3 times 4. And I want negative 4 and a positive 3, so I can add up to a negative 1. Okay, now that I have my factors, I'm going to write this out. I have a 5 times 6x squared minus 4x plus 3x plus minus 2, 3x minus 2. There we go. Now I'm going to write these terms into two distinct binomials. And I'm going to find the GCF. So my first binomial, it looks like I can remove a 2 and an x. 6 divided by 2 is 3. 2 minus 1, I've got x. Negative 4 divided by 2 is negative 2. Excuse me, I almost tried to make a positive 2 there. And 1 minus 1, goodbye to the x. Now, greatest common factor here is going to be a 1, and I'm left with 3x minus 2. And I'm going to have this all nice and factored now. And if I recall, in my original problem, 3x minus 2 was in the denominator. That will cancel, and my answer is 5 times 2x plus 1. All right, next two problems are going to be our geometry applications. If I have the area of a rectangle, this is the trinomial of representing the area of a rectangle. Remember, a rectangle area will equal length times width. So I'm looking for two factors. Well, trinomials factor into binomials. So let's A equals 2, B equals 7, and C equals 6. When I draw the big X, I've got 2 times 6, which is 12, and 7. This is one of my favorites because I know 3 times 4 is 12, and 3 plus 4 is 7. So now that I found my factors, I'm going to write this out. I've got 2x squared plus 3x plus 4x plus 6. All right, let's write this into two distinct binomials. And now I need to remove the greatest common factor. Well, no numerical greatest common factor here, but I can remove an x. So 2 minus 1, 1x left. 1 minus 1, 0x is left. In my next binomial, it looks like 2 is going to be my greatest common factor. 4 divided by 2, 2x. 6 divided by 2 is plus 3. So it looks like when I factor this trinomial, I have x plus 2 and 2x plus 3. And does it matter which one is the length and which one is the width? No. This is my answer. One is length, one is width. So now it says to find the actual dimensions if x equals 3 centimeters. Now I'm going to say that length equals x plus 2 and width equals 2x plus 3. It doesn't matter if I switched it. So if I substitute 3 in here, length equals 3 plus 2, so length equals 5 centimeters. If I substitute 3 here, I've got 2 times 3 plus 3, and width is going to equal 2 times 3, which is 6, plus 3, which is going to equal 6 plus 3 is going to equal 9 centimeters. There are my answers. Last problem on this is going to have us factoring to find the length, width, and height of a rectangular prism. So volume, the volume of a rectangular prism is length times width times height. It looks like I already know that the height of the prism is x, so h equals x. And I'm looking for length and I'm looking for the width. So let's take a look at this trinomial. And I'm going to see if I can find a greatest common factor. And indeed, it looks like I can remove x from each term. So I've got 3x squared, 3 minus 1, 13x minus 10. So now here's my height. I'm looking to find the other two factors that will multiply to get my volume. So I'm going to draw my big X. I'm going to identify A as 3, B as 13, and C equals negative 10. 3 times negative 10 is negative 30, and B is 13. Thinking about my factors of 30, 1 times 30, 2 times 15. 15 minus 2 is 13. So if I have a negative 2 and a positive 15, I've got factors that work. So writing this out, I've got 3x squared. I'm going to put the minus 2x first, and then the plus 15x minus 10. Write that as two distinct binomials. And now to look for the greatest common factors. So keeping that x there, there's my height. When I look at this first binomial, no numerical, but I can remove an x. And it looks like then I have 3x minus 2. In my second binomial, can't remove a variable, but it does look like I can remove a 5. 15 divided by 5 is 3x, negative 10 minus 2. And happily, I have resulted in a place where I have x times 3x minus 2 times x plus 5. And so these are the expressions that will be length and width. And it doesn't, again, matter which one is which. So let's just say this is length and this is width. If you put it the opposite way, absolutely fine. That's all for this video. Thanks so much.